Today we're starting chapter 9, which is over the coordinate plane. And you can see our big idea is that every point on the coordinate plane can be represented by a pair of coordinates. So that's known as plotting the points. And we're going to connect those points, and you'll see that we have a grid for that. So when we connect them, you might find like A1 or something like that you can see on your textbook, page 38, where you are starting the chapter. So you see the map, and if you find the location at grid point B2, you can see that it's boxed in. So we're going to recall a couple of things. So first, if I was going to plot the point 3, 4, so first, this is the x-axis, and this would be the y-coordinate. So I would go across the x first. I always go across, and then I go up and down. Okay, down would be negative, up is positive, just like on my x-axis. To the left is negative, and to the right is positive, so it's like a number line. The horizontal number line to the left is less, to the right is positive. If I have a vertical number line, down is negative and up is positive. So if I'm going to plot the point 3, 4, I would go across to 3 and go up 1, 2, 3, 4. And I'd put a point right there. And remember, it's equal to that point, so we fill it in. We don't put an open dot. And I would label it B because it's point B. Otherwise, I'm going to have a bunch of dots on here, and I won't know which point is which. So just one more. If I was going to do -1, 4, so then I'd go -1 because I go x first, which is the cross. So I go to the -1, and then I go up 1, 2, 3, 4 right there, and that would be C. Okay, and then if you look at number 6, we're just remembering the absolute value of 11 is equal to 11, and the absolute value of 16 is equal to, of -16 is equal to 16. And then if I had the negative sign on the outside of an absolute value, I'd find the absolute value first. So the absolute value of 21 is 21, and then I'd put the negative sign back on. Okay, and if you look at number 9, it says figure ABC is an isosceles triangle. So isosceles means equal on two sides. And I always remember that because there's two S's in there on the side of the O. So if it's equal on two sides, then I want to define the perimeter. I have 8 here, I had the 5 here, and I know this is 8 because those would be the two sides that are equal because it tells me the lines there. So 8 plus 5 is 21 inches. And then if it says it's an equilateral triangle, that means all sides are equal. A trapezoid would mean I have parallel sides, and that these sides would be equal. So those are 9 and 9, 10 and 16. This is 11. So then you could find the perimeter and add it all up, which would be 44 centimeters. I'll change that one to number 12. So number 12, a parallelogram, means opposite sides are parallel and equal, but it's not a square, so they don't all have right angles. So this is 8, this is 7, so I would know this would also be 8, and this would also be 7. So I could find the perimeter. So 8 and 8 is 16, 7 and 7 is 14, 16 plus 14 is 30 centimeters. And then a rhombus, also, the opposite sides are parallel and equal. So we're going to move on to lesson 1, which is points on the coordinate plane. So the big idea is obviously the same, that we can find points on the coordinate plane, and those are represented by a pair of coordinates. So our objective for lesson 1 is to name and locate those points. and to draw and identify polygons. On the coordinate plane. You see you have several vocabulary words here that you need to make sure you do before you turn in the chapter notes. Okay, so we have this right here. We're going to start in quadrant 1, which you can always remember quadrant 1 is the one that you work in where the x-axis is positive and the y-axis is positive. So this is the one where you have been most used to working in so far. Lots of times it'll zoom in on just that quadrant. Okay, so positive and positive. And then we go around counterclockwise. So it goes counterclockwise. And so this would be quadrant 2. And the x-axis here, you can tell would be negative. And the y-axis is positive. And then you guessed it, we have quadrant 3, because quadrant 1, 2, 3. So here, the x-axis you can see is negative, and the y-axis is also negative. And then we end at quadrant 4, where the x-axis is positive, and the y-axis is negative. So if you notice across from each other, so the x-axis here is negative, whereas the x-axis here is positive. The y-axis is positive here, and it's negative here. So if you take the opposite corners, they're the opposite operation. If I have the opposite corners here, it's the opposite operation. So quadrant 1 is positive, positive. Quadrant 3 is negative, negative. So if you had a coordinate that was -3, -4, you would know that should be in quadrant 3 somewhere. So we're going to look at number 5 here for guided practice. So it says use graph paper, which you already have here for you. Plot the given points on the coordinate plane, then join the points in order, that makes a difference, with line segments to form a closed figure. So if you don't have a piece of paper or a flat edge, you can use a ruler, or you can just use your planner as a straight edge. Anything will work. So first we're going to plot point A, which is 3, 4. So you go out 3 and up 4, and that's point A. Make sure you label the points or you'll miss points for the label. And then B is -6, -3. So they're both negative. We know it should be in quadrant 3. So quadrant 1, quadrant 2. Remember these were positive, positive. This was the x-axis was negative and the y-axis is positive. Here they're both negative. And here the x-axis is positive and the y-axis is negative. So you can also see that on the bottom, the y-axis is both negative, whereas on the top, the y-axis is both positive. On the right side, you can see the x-axis is positive, whereas on the left, the x-axis is both negative, which corresponds with the number line. So it said to connect them in order. And then C is at 2 and -4. And then you need to connect it back to the start. And so you have a figure, and it says name each figure formed. So I would say this is a triangle. If you know the specific type of triangle it is, you could say that as well. Okay, and then number 12 says J is -4, 1. K is -3, -1. L is 0, so I don't move anywhere across. I just leave it there. And -1. And then M is 2, and then 1. And then you connect the M back to the J, and you could say this is maybe a trapezoid. I think my M is wrong. It should be at 2 and then 1, so it should be here. It looks more like a trapezoid now, so trapezoid. Sometimes you might have to say quadrilateral. So the practice is similar to that. On number 1, it's going to want to tell you what quadrant it is, so give the coordinates of each point. So A, you're going to have to determine where the points are from your book. So if you look at it, you would then determine that A is at 2, 6, and then which quadrant it is in, which we know A is in quadrant 1. And then if I look at D, we're going to skip down to that. It's at 4, and then -9. And D, remember they go counterclockwise, so quadrant 1, quadrant 2, quadrant 3, quadrant 4. So D was here on your book, so D would have been in quadrant 4. Okay, let's do one more. C is at, if I go across, it's at 3. And then does it go up and down at all? And the answer would be no. So it's at 3, 0. And you could say it's in quadrant 1 or quadrant 4, but that wouldn't be correct. Technically, it's on the x-axis between quadrant 1 and quadrant 4. So it's at C. Okay. And then when we do these ones where we're reflecting across the x-axis, I want you to think about a mirror. And in a mirror, you would look at your image on the opposite side of the mirror. So if you're reflecting across or about the x-axis, you would highlight the x-axis. And you could plot point A. So you'd have 4, 1 here. And you're going to reflect across the x-axis. So you'd go 1 here and then 1 to the other side, and you'd plot the reflection there. So you can draw a dashed line if you need to. There's 1 to the x-axis and then 1 to the other side. So this would be point B at 4 and then -1. And what you'll notice is the x-axis should stay the same. When you're reflecting about the x-axis should stay the same. The y-axis should become the opposite coordinate. So if you try number 4, it says -2, 3. So remember the x should stay the same. So we should have a -2, and then the y should be the opposite. So we're guessing it should be at -2, -3. Let's plot it and see. So A should be -2, and then 3. And then B would reflect across, so it comes down 3, and then goes down 3 from there. So B would be a reflection at -2, -3, which that stayed the same, and the y changed. Okay. And then be careful when it says in switches, reflection about the y-axis. That's just the opposite of that. So in this one, if we were reflecting across the x-axis and the y was the opposite and the x was the same, what do you think is going to happen?